In this example, we have a ball that is tossed in the positive y direction and reaches a maximum height after 1.5 seconds. What is the maximum height of the ball? Alright, so we have a ball tossed in the positive y direction, and there's no rocket engines attached, which tells us that we're in a free fall problem. So that tells us our acceleration is going to be the negative 9.8 meters per second squared. And because the negative 9.8 meters per second squared is constant, we can use our constant acceleration equations, or our kinematic equations. And it reaches a maximum height after 1.5 seconds. So that tells us that our time is 1.5 seconds. And it says maximum height. And remember, at maximum height, your velocity is 0. So that means velocity final is going to be 0. So our goal here is to find displacement. And if we look at our displacement equations, they all have initial velocity in them. Which means in order to solve this problem, we have to find the initial velocity first. The initial velocity is not 0. It can't be 0 because otherwise the ball would never travel in the positive y direction. So before we stepped into the problem, the person pushed upward on the ball. So I'm going to use the fact that velocity final equals velocity initial plus acceleration times time in order to establish what my initial velocity is. So I plug in 0 for my final velocity. Velocity initial is my unknown. My acceleration is the negative 9.8 meters per second squared. And then I'm going to multiply by the 1.5 seconds. So expanding the math a little bit, we have 0 meters per second equals velocity initial plus, when we multiply the 9.8 times the 1.5, we get negative 14.7. And if we look at the units, meters per second squared times seconds, the seconds on top cancel out, we lose 1 second on the bottom, we get units of meters per second. I then can add the 14.7 to both sides, so that I get 14.7 meters per second equals the initial velocity. Now that I know what the initial velocity is, I can use one of my other equations that contain displacement in order to find the displacement, or the maximum height. So I chose to use displacement equals velocity initial times time plus 1/2 times acceleration times time squared. So I took my 14.7 meters per second times 1.5 plus 1/2 times the negative 9.8 meters per second squared times 1.5 seconds quantity squared. And that gives me 11 meters. So let's break that down a little bit. 14.7 times 1.5 is equal to 22.05 meters. And we know it's meters because we have meters per second times second. The seconds on top and bottom cancel out, and we're left with just units of meters. And we're going to do plus and negative. If we take 0.5 times 9.8 times 1.5 squared, that's going to give us 11.025. And if we look at our units once again, we have meters per second squared times, and since we squared the time, it's now seconds squared, so the seconds squared cancel out, top and bottom, we have units of meters, which means we can add them together. So when we take 22.05 minus 11.025, we get about 11 meters. So that's the maximum height that the ball goes above its initial position.